Imagine a lake freezing over. The water turns to ice, but it doesn't freeze perfectly. Different patches of ice form at different angles, and where they meet, you get a jagged line, a crack, a flaw in the structure. Physicists believe that when the universe was born, it went through a similar freezing process. Immediately after the Big Bang, the universe was hot and unified. But as it expanded, it cooled down. It went through a phase transition, like water turning to ice. And just like the lake, the universe didn't freeze perfectly. There were boundaries where different regions of space-time met, but didn't quite line up. These boundaries trapped the high-energy state of the early universe inside thin, infinite tubes. These are cosmic strings. They are topological defects. They are essentially cracks in the fabric of reality that never healed. They are almost impossible to visualize. A cosmic string is thinner than a proton. It is less than an atom wide. But because it contains the trapped energy of the Big Bang, it is unfathomably heavy. A single inch of cosmic string would weigh as much as Mount Everest. A mile of it would weigh more than the Earth. They form giant loops that wiggle and whip through the universe at nearly the speed of light. They are invisible lines of pure, concentrated gravity, and they are out there right now, thrashing around in the dark. Scientists look for their echoes in the cosmic microwave background, the leftover heat from the dawn of time. If a cosmic string passes between us and a distant galaxy, its massive gravity can split the light, creating two identical images. When these giant loops collide or snap, they release bursts of gravitational waves, ripples in the very fabric of space. Detecting these waves would be the ultimate proof that these cosmic fossils actually exist. They are primordial relics, left over from the moment the universe first took shape. Some theories suggest they might have even acted as seeds, pulling matter together to form the first galaxies. Whether they are real or just a beautiful mathematical prediction remains one of the greatest mysteries in physics. Hidden in the dark, cosmic strings remind us that reality itself might be more fragile and more flawed than we ever imagined. What happens if you touch a cosmic string? It sounds like sci-fi, but the physics is terrifyingly real. Imagine an invisible filament, thinner than an atom, drifting into our solar system. You wouldn't see it, but its gravity is immense. It doesn't pull you in like a planet. It pulls space itself around it, creating a literal, conical defect in the fabric of the universe. If a cosmic string whipped through the Earth, it wouldn't crash. It would slice, like a hot wire through a block of cheese. Passing through in a fraction of a second, the gravitational shear would trigger global earthquakes instantly. But for a human body, it's subatomic. It severs the very bonds holding your molecules together. The scariest part? The radiation, the wake of the Big Bang itself, would boil you from the inside out in a heartbeat. It is the ultimate cosmic weapon, a gravity lightsaber that stretches across the entire observable universe. Cosmic strings aren't just destroyers, they might be doorways. In 1991, astrophysicist Richard Gott discovered that two cosmic strings passing each other at high speed could actually bend time. This calculation showed that these cracks in space-time don't just bend space, they bend time. This creates a closed time-like curve, essentially a mathematical time machine. By flying a spaceship in a specific figure-8 pattern around these strings, you could arrive back at your starting point before you even left. This is one of the only forms of time travel mathematically allowed in general relativity. It follows the laws of physics perfectly, requiring no negative matter or unstable wormholes. Advanced civilizations could manipulate these scars of the Big Bang to build highways to the past and literally rewrite history. The cracks in our universe might just be the way back home. Thank you for watching. So, where are they? We haven't seen one yet, but we have seen hints. Astronomers look for gravitational lensing. Because cosmic strings are so heavy, they bend light. If a string passes in front of a galaxy, it should act like a lens. It should create a double image. We would see two identical copies of the same galaxy, right next to each other. In 2003, a team of astronomers found a candidate, CSL-1. It was two galaxies. They looked identical. They had the same spectrum. They were undistorted. It looked exactly like the signature of a cosmic string blocking the view. The scientific community held its breath. Was this the proof? Later, Hubble telescope images showed that CSL-1 was likely just two real galaxies merging, but the hunt continues. We are looking for the Kaiser-Stebbins effect, a sharp jump in temperature caused by a string moving across the baby universe. Finding a cosmic string would be the holy grail of physics. It would prove string theory. It would prove the multiverse. We are living in a cracked crystal. A thread of infinite energy is whipping through the dark. I am your host. Watch for the double image. Subscribe.